Welcome back to the Tank Engineering Academy API 650 Masterclass course series. This is Module 2, Foundation Engineering, and today we begin Lesson 2A, Soil Investigation. If you missed our previous lessons, I highly recommend watching them first because every lesson builds on the previous one. Before we continue, please like, subscribe, and turn on the notification bell so you won't miss our upcoming lessons on storage tank engineering, API 650 construction, inspection, maintenance, project management, and engineering best practices. Let's begin. Course progress. Today we are in API 650. Masterclass to Module 2, Foundation Engineering to Lesson 2, A, Soil Investigation. Upcoming lessons include Lesson 2B, Ring Wall Foundation Design. Lesson 2C, Foundation Settlement. Lesson 2D, Foundation Construction. Lesson 2E, Foundation Inspection. Lesson Objectives. At the end of this lesson, you will understand what soil investigation is, why soil investigation is important, types of soil exploration, field testing, laboratory testing, geotechnical report. Checkmark how soil investigation affects API 650 tank design. What is soil investigation? Soil investigation is the engineering process of determining the physical and mechanical properties of the ground before construction begins. It tells engineers what type of soil exists, how strong the soil is, how much load it can support, whether groundwater exists, how much settlement may occur. Without soil investigation, engineers would simply be guessing. For storage tanks, that can lead to excessive settlement, shell distortion, bottom plate failure, piping damage, and even catastrophic tank failure. Why is soil investigation important? Storage tanks exert tremendous loads. Imagine a crude oil tank, diameter 80 meters, height 20 meters, product weight more than 80,000 tons. All of that weight is transferred into the foundation. If the soil cannot safely support the load, the entire tank will settle. Settlement can lead to uneven shell stresses, bottom plate deformation, floating roof problems, nozzle overstress, pipe misalignment, foundation cracking, tank leakage. This is why geotechnical investigation is one of the very first activities performed on a new tank project. Objectives of soil investigation. The investigation aims to determine soil classification, bearing capacity, allowable soil pressure, settlement characteristics, groundwater level, soil density, compaction characteristics, liquefaction potential, corrosive properties, seismic characteristics. These parameters become the basis of foundation design. Soil exploration methods. Common methods include boreholes, the most common investigation method. Engineers drill into the ground to collect soil samples. Test pits, excavated pits used for shallow foundations. Cone penetration test, CPT, measures soil resistance using a hydraulic cone, very effective for sandy soils. Standard penetration test, SPT, probably the most widely used field test. A split spoon sampler is driven into the ground. The number of hammer blows required is called the N value. Higher N value generally means stronger soil. Field tests. Several field tests may be performed. Standard penetration test, cone penetration test, plate load test, pressure meter test, vein shear test, permeability test. Each provides different information used by geotechnical engineers. Laboratory tests. After collecting samples, they are tested in laboratories. Typical laboratory tests include moisture content, Atterberg limits, grain size analysis, specific gravity, compaction test, triaxial test, direct shear test, consolidation test, chemical analysis. These determine how the soil behaves under load. Soil types. Engineers commonly encounter clay, silt, sand, gravel, rock. Each behaves differently. Clay may experience significant settlement. Sand usually provides better bearing capacity. Rock offers the highest foundation support. Groundwater. Groundwater significantly affects foundation design. A high water table can reduce soil strength, increase settlement, cause uplift pressure, complicate excavation, increase corrosion risk. Proper drainage systems may be required. Geotechnical report. At the end of the investigation, the geotechnical engineer prepares a report. This typically includes project information, site description, borehole logs, groundwater level, laboratory results, soil profile, bearing capacity, settlement analysis, foundation recommendations, construction recommendations. This report becomes one of the most important design documents for the project. Application to API 650 tanks. For API 650 storage tanks, the geotechnical report helps engineers determine ring wall dimensions, foundation type, sand pad thickness, compaction requirements, ground improvement, settlement limits, drainage systems. Without accurate soil data, safe tank design is impossible. Common mistakes. Avoid these common mistakes: skipping soil investigation, too few boreholes, ignoring groundwater, poor sample collection, using outdated geotechnical reports, ignoring settlement predictions, poor communication between civil and tank engineers. Key takeaways. Remember these important points. Soil investigation is the foundation of foundation engineering. It determines whether the ground can safely support an API 650 storage tank. Field tests and laboratory tests provide essential engineering data. The geotechnical report guides foundation design, construction, and long-term tank performance. Next lesson. In our next lesson, Module 2, Foundation Engineering. Lesson 2, B, Ring Wall Foundation Design. We will discuss ring wall components, design principles, reinforcement, concrete specifications, construction sequence, common failures. Outrow. Thank you for watching another lesson in the Tank Engineering Academy API 650 Masterclass course series. If this lesson helped you better understand soil investigation, please support the channel by liking this video, subscribing, and sharing it with fellow engineers, inspectors, supervisors, and students. Don't forget to leave your questions in the comments. We read them and use your feedback to improve future lessons. Keep learning, keep building, keep engineering with excellence. See you in Module 2, Lesson 2, B, Ring Wall Foundation Design. God bless and thank you for watching.